Hypothalamus Artificial Intelligence, HI. Digital transformation with artificial intelligence and real-time optimization. At HI, we take mathematical optimization to the next level with OPTEX-GAMS, our platform designed especially for GAMS users. As GAMS business partners, HI offers training courses in GAMS, from basic to advanced level. These courses can be adapted to the needs of each industry, providing practical tools to apply mathematical optimization in different sectors. This presentation is related to the GAMS environment. Link OPTEX-GAMS. It is a virtual world, parallel to the real world. What we seek is to compare what management thinks of the real world with what that world really is, to explain how much it understands and knows the reality in which it operates. To the extent that the mathematical model explains and reproduces the real world, there is a laboratory with which the impact of decisions can be analyzed, learned from them and built an enriched mental model that guarantees good decisions. If there is no mathematical model, decisions will be supported by the mental models of every human being, which are never contrasted and, therefore, in many cases it is not known on what basis we support the decisions. A mathematical model is a pure representation of mathematical symbols, devoid of specific data. In contrast, an instance is the numerical representation of a model with its actual data. In an instance of the model, some expressions are solved into their individual components, and equation domains are solved into individual scalar equations. A mathematical modeling professional never, perhaps only the first time, implements an instance of a mathematical model, implements the algebraic model, and then, including the data, generates the instance that produces the results. For this reason, RCADT does not teach how to deploy direct model instances in GAMS. HI's knowledge encompasses all advanced modeling techniques, including the data model of the database, designed to facilitate the generation of the instance model that joins the algebraic model with the database. From the point of view of organizational management, it can be said that the three models are equally important. The results that are sought, which will become decisions, are produced by the model instance. The modeling effort must be done in all directions. HI is a knowledge factory dedicated to developing its computer platform based on artificial intelligence, using a unique vision at a global level. HI stores all its models using OPTEX, Optimization Expert System, for the development of multi-problem mathematical models, and using the principles of generative artificial intelligence to produce the algorithms and all the software used by HI's solutions, without programmers. HI has established an alliance with GAMS, General Algebraic Modeling System Incorporated, to jointly produce optimization solutions using mathematical programming. The General Algebraic Modeling System, GAMS, is a high-level modeling system for mathematical optimization. It is designed for modeling and solving mathematical programming optimization problems. GAMS is tailored for complex, large-scale modeling applications, and allows you to build large maintainable models that can be adapted quickly to new situations. Models are fully portable from one computer platform to another. The HI-GAMS Alliance is able to solve complex problems by facilitating the diffusion of mathematical programming. Value Chain Optimization. MOS is an advanced decision support system, DSS, made up of multiple mathematical models, predictive and prescriptive analytics. These models are the same as those used by large companies, the big difference is their cost of access. MOS socializes current analytical technologies, mainly those related to artificial intelligence, machine learning and mathematical programming. In this way, companies increase their value, by fully entering the new world, generated by the digital transformation of Industry 4.0. SaaS is the technology that allows access to software applications on the web. For many years, programs were installed on the user's computers. This was in the past, because the trend points to cloud computing. When the software corresponds to complex algorithms, to solve mathematical problems, HI calls this service Mathematical Models as a Service, MOS, a software distribution model, which works thanks to the fact that HI develops mathematical models, and makes them available to users, through a subscription via the Internet. All the elements that make up the mathematical models, such as the algorithms and their computational codes, as well as the hardware, remain unchanged, and are managed and maintained by HYPOTHALAMUS replaces the traditional provision of on-prem software, in which the customer buys the rights to use mathematical models, to run them on their own computers, which can be in their private cloud, or in a public one. In this case, the following should be considered. Solver licenses, or the right of access on the web, must be provided by the end customer. The models are sold as executable codes, and in some cases the source code can be supplied. To have the latest version of these licenses, HY will instruct the MOS user to request a license as a demo for proof of concepts. GAMS is one company chosen by HY to provide server hosting and licensing services. Another company that provides optimization technologies can be selected, but each company has its own tools. All the elements analyzed must be considered when deciding on the most convenient architecture for the MOS service, whose main characteristic is its dynamics, since its components and capabilities can be adjusted to the customer's workload. The basic architecture has 4 types of components: optimization server, optimization database, and MOS, business user server. Workstations in the client. The amount of power of servers that are used at any given time can vary. As a standard configuration, HY proposes to use a CPU cluster. Below are the main things to consider when defining the settings to use at any given time. If you are interested in learning more about the MOS, HY invites to watch the video. Mathematical Models Software Factory. When the client requires specialized models, HYGAMS offers the services to design and implement models in a short time, and at manageable costs for all types of companies. Mathematical Models Software Factory is a service offered by HY in which the client provides HYGAMS with the formulation of the mathematical model and a test database, and HYGAMS provides the client with a decision support system composed of source code of the mathematical model and the selected optimization technology, information system data model, and, if it exists, a test case to test the correct functioning of the model. The diagram presents the MOS client-server architecture, based on super servers. The current state involves the integration of edge computing and cloud computing, to implement an enterprise-wide optimization system, composed of multiple highly complex mathematical models. The integrated model, an artificial brain produced by HY, can be distributed across various types of computers. Artificial brains are backed by the technological power of computing. It is traditional to associate mathematical modeling with large-scale computing, which today is linked to cloud computing, made up of bit supercomputers, and the birth of quantum computers, and their commercialization process, which will be by runs of applications, which will be solved in the blink of an eye. As a standard configuration, HY proposes to use a CPU-S cluster with many GPUs. This implies that applications are deployed using intelligent devices based on the symmetrical atomization of systems and/or processes. As is the case with GPT-based artificial intelligence. Soon, HY hopes to offer the OPTEX-GPU solver, as a CPU-S network specialized in solving optimization problems. This possibility is not available at this time. The computational support of a large company will integrate multiple types of specialized servers, all of them supplied by third parties, which must guarantee their correct operation. This central computing system will be accessed by users of companies that use MOS, working in an external logical network. The company's data and application servers will be located at this same layer. As we have seen, there are multiple architectures that a company can implement to meet its needs. The economic implications vary with the user's decisions and needs. At this level of the proposal, the following configuration has been assumed. In the cloud, optimization server provides compute time hosting, optimization platform licenses, and mathematical model licenses. Optimization database, temporary files used by HY mathematical models. On the client, company database, permanent files used by the company, and potentially read by HY's mathematical models. Business user, cloud optimization system access workstations. GAMS provide the optimization services in the cloud. One of the great advantages of MOS is that the user can be an SME, small and medium-sized company that would otherwise not be able to access advanced artificial intelligence. The image presents the components that have to do directly with optimization, whose capacity must be designed, and that generate costs that the user must assume. The first element to consider is the multi-core and multi-threaded CPU, its architecture, and the software components it stores, which are presented below. Multitasking. A multitasker is one that can perform two or more tasks simultaneously and efficiently, which, saving distances, would be something like what a computer does. Today, operating systems can run multiple programs simultaneously instead of running them sequentially. This is known as multitasking. Multitasking doesn't necessarily need multiple physical processors or multiple cores. A single processor and even a single core can share time between multiple processes. Today, processors work so fast that we have the illusion that all multiple processes run in parallel. If the computer has multiple processors or cores, different processes or tasks can be executed in a truly parallel manner. It should be noted that all processors share RAM. If you have many processors and very little memory, the parallelism effect may be lost due to inter-process interference, which can bog down the machine. Each process can create threads, known as threads, which are independent sequences of code statements. Multiple threads within the same process can communicate and share resources. Multithreading is used to improve the performance of an application by splitting sequential instructions into multiple parts. For example, a server-based application uses multiple threads to handle multiple requests simultaneously. The evolution of multithreading is in constant motion and has been the center of superservers. Depending on the CPU type, a fast cache is used to access commonly used data. Access to the CPU cache is faster than that of the main memory, RAM. Typically, the data cache is organized as a hierarchy of multiple cache levels L1, L2, and so on. The L1 cache is the fastest cache and usually comes inside the processor chip itself. It uses high-speed SRAM, static RAM, instead of the slower and cheaper DRAM, dynamic RAM, used for main memory. The L2 cache is located between L1 and RAM and is larger than L1. There may be a third-level L3 cache, depending on the type of CPU. Each core can have its own local L1 cache. There are multiple architectures for multi-core and multi-threaded computers, which becomes one more variable to be resolved. Clock speed measures the number of cycles a CPU runs per second, measured in gigahertz. During each cycle, billions of transistors inside the processor open and close. The higher the clock speed per core, the better. In recent years, a new supercomputer architecture has emerged, based on the power of parallelism provided by GPUs, graphics processing units manufactured by NVIDIA. This architecture is today the basis of the supercomputers that power GPT artificial intelligence. NVIDIA ChuOpt is a GPU-accelerated, open-source solver for decision optimization, excellent in mixed integer linear programming, MILP, linear programming, LP, and vehicle routing problems, VRP. Designed to address large-scale problems with millions of variables and constraints, ChuOpt enables near real-time optimization, resulting in significant cost savings. With a record in the mixed integer programming library, MIPLib, and 23 world records and routing benchmarks, ChuOpt delivers breakthrough performance in solving complex real-life optimization problems. To use GAMS with ChuOpt, you will need a Linux operating system, an NVIDIA GPU, and GAMS version 49 or newer. The research realized by Lamani et al. Consists of the implementation of the simplex algorithm in a multi-GPU architecture, using CUDA, NVIDIA Compute Unified Device Architecture for GPUs. Computational tests have been carried out on randomly generated instances for non-sparse LP problems. Tests show a maximum acceleration of 24.5 times with 2 Tesla C2050 cards. Dense linear programming problems occur in many important domains. Large-scale algorithms, such as Bender's and Danzig-Wolf, result in dense LP problems. This aspect is fundamental when the memory of the process is included in artificial brains. In addition to the effect of the hardware of computers oriented to parallel processing, nowadays practically all of them, you have to know the software to see how it will work in the selected option. In high algorithms there are different implementation options that make different use of parallelism. Each release involves variations in algorithms and therefore variations in cost. The graph presents the effect of the parallel implementation of the standard high-power/mod plan algorithm. The effects are: no parallelism, reduced use of system resources, and longer time to solution. With parallelism, increased use of system resources, and shorter time to solution. Each bar indicates the acceleration ratio calculated as the sequential time divided by the parallel time. It is clear that the parallel solution is faster. Any parallel algorithm can run in two versions. Asynchronous, each version of the algorithm runs at the highest speed, and usually, when vacated, it restarts the cycle, and synchronous, there is a point of synchronisms, in which all algorithms must wait for the last one to finish the cycle. It is used for the control and analysis of algorithms. The image compares monolithic optimization solutions versus large-scale optimization solutions. To do this, the asynchronous version of Benders is run for all instances, running until the same optimality gap is reached as with C-Plex after 10 hours. All algorithms run on 15 processors. The C-Plex time divided by the Benders time indicates how many times a monolithic solution, represented by C-Plex, is slower, compared to a solution that uses large-scale optimization, arriving 519 times slower in the most complex instances. The image shows the performance comparison of the additional processors, in which it is shown that the analyzed algorithm, as the processors increase, the marginal performance gain decreases. HY's approach to developing large-scale superalgorithms using linear programming models as the core, in this case using C-Plex. Similarly, problems that need to be solved with different methodologies on a large scale can be shared. From a central set of equations, each problem can be adjusted according to the algorithm to be used. GAMS environment. GAMS is a high-level software for mathematical modeling that allows to address the challenges of mathematical programming in a simple and effective way. It is especially useful for building and solving large and complex problems, which can be quickly adapted to new situations. This system consists of a powerful one-pass compiler for algebraic language and a wide range of associated solvers. A single-pass compiler implies that it is the modeler's responsibility to sort the elements of the model, so that they are directly understood by GAMS. Thanks to the GAMS modeling language, modeling experts can quickly and efficiently translate real-world optimization problems into computer code. GAMS compiler is responsible for translating that code into a format that is understandable by the solvers. GAMS architecture offers exceptional flexibility by allowing to change the solvers without modifying the model formulation. GAMS offers the user two interfaces: GAMS IDE, the traditional, and GAMS Studio, which commercially replaces GAMS IDE. For more than 20 years, the GAMS IDE served as the primary development environment for many GAMS users. As development practices and expectations evolved, the underlying technology of the GAMS IDE limited the ability to add modern functionality. To meet current and future needs, a new development environment was created from scratch, GAMS Studio, which is a fast, reliable, and platform-agnostic environment, such as Windows, Mac OS, and Linux, offering a modern and powerful environment for programming in GAMS. For more than 20 years, the GAMS IDE served as the primary development environment for many GAMS users. As development practices and expectations evolved, the underlying technology of the GAMS IDE limited the ability to add modern functionality. To meet current and future needs, a new development environment was created from scratch, GAMS Studio, which is a fast, reliable, and platform-agnostic environment, such as Windows, Mac OS, and Linux, offering a modern and powerful environment for programming in GAMS. GAMS IDE. GAMS IDE is a general text editor with the ability to launch and monitor the compilation and the execution of GAMS models. The progress of a build and run can be monitored in the process window, that is a navigation tool to locate syntax errors in the source code and find various anchor points in the listing file. GAMS IDE also makes it easy to select default solvers and manages GAMS parameters on a file-by-file basis. Some new features are not available in versions prior to version 95. The online help only covers the use of GAMS IDE, not the GAMS language. However, there is a mechanism to access GAMS documentation from the publisher, by checking the Help menu option in the main window. The interactive nature of the Windows environment often makes it difficult to reproduce a user-reported program error. The screenshot shows an image of the GAMS IDE browser. GAMS Studio. GAMS Studio. A multi-platform, PCs with Windows, Mac, Linux, graphical interface to run GAMS. GAMS Studio uses two phases. Text edit. First, one uses a text editor and creates a file which contains GAMS instructions. File submission. Second, one submits that file to GAMS which executes those instructions, causing calculations to be done, solvers to be used, and a solution file of the execution results to be created. Approaches to use GAMS. Traditional, more batch-oriented methods: they use a text editor, configure the model, and then employ Windows, or Linux, command line statements to find errors and solve the model. The visual interfaces, GAMS Studio or GAMS IDE, can create, debug, edit text, and run GAMS files. The screenshot shows an image of the GAMS Studio browser. GAMS offers 4 tools for users. GAMS Studio, user interface such as GAMS IDE interface, GAMS Miro, new user interface, offered to the optimization market since 2019, GAMSP, a tool aimed at Python modelers, and GAMS Engine, manager of services on servers. GAMS Miro is the user interface, offered to the optimization market since 2019. For more information you can see the video. Interactive web application with GAMS Miro v1.1. Initially, Miro is launched without any additional configuration. However, later you will find many configuration possibilities to adapt Miro to a specific model. Configuration is done using a graphical interface, with which you can create graphics and widgets, or change certain settings with a few clicks of the mouse, visually supported by a live preview. Configuration can also be done manually using a JSON file. In fact, what graphical configuration mode does is create this JSON file. GAMSP. Especially in the case of complex models with many variables and equations, an instance of a model can be difficult to manage, an instance of GAMSP. It is based on the idea of an indexed representation of a mathematical model. This approach preserves the essence of the original algebraic formulation while ensuring manageability, even in the face of intricate complexities, for example, complex assignments of indices to subsets. Creating robust, readable, and maintainable models is an art based on algebraic formulation. The ability to express mathematical models in a language that preserves the essence of algebraic notation and is machine processable is critical. With this goal in mind, GAMSP has been developed to be able to generate mathematical models instead of instances of models. GAMS is a domain-specific declarative language that incorporates procedural elements of a general-purpose programming language, such as loops and conditional statements. Python is a general-purpose programming language where these elements are already inherent. With the integration of the GAMSP library, functions such as indexed mapping statements, or concise equations of the GAMS domain-specific language are now available in Python. This facilitates a seamless connection between the specialized modeling capabilities of GAMS and the flexibility and versatility of Python. When delving into the complexities of modeling languages, a key aspect of any modeling language is how it manages dispersed multidimensional data structures. Real-life optimization problems are subject to a particular structure in which the data cube has many zeros and only a few non-zeros, a feature known as sparsity. In optimization problems, it is often necessary to consider complex index mappings to subsets. While you may be used to taking full responsibility for making sure that only relevant combinations of indexes make it into your definition of variables in the world of Python modeling, we especially focused on transferring the convenience and mindset of GAMS to Python when designing GAMSP. Therefore, GAMSP is automatically responsible for generating variables only for the relevant combinations of indices based on algebraic formulation. This feature is especially useful when working with a large multidimensional index space, where generating all index combinations would be computationally expensive and unnecessary. GAMSP quietly takes care of this task in the background, allowing you to focus on model formulation. GAMSP leverages the GAMS backend to execute assignment operations, generate, and resolve models. Since GAMS has been optimized for decades for exactly these tasks and comes with an extensive set of state-of-the-art optimization solvers, it provides exceptional performance for model generation and resolution. This is the main source of GAMSP's speed. Working on an optimization problem not only includes the mathematical model, but also includes tasks related to data pre- and post-processing, as well as visualization. GAMS prioritizes making these tasks as comfortable and efficient as possible. GAMSP provides a unique way to streamline the entire optimization process, starting with data input and pre-processing, followed by mathematical model implementation and data post-processing and visualization, in a single, intuitive Python environment. GAMSP allows to leverage the favorite Python libraries, such as NumPy, Pandas, NetworkX, to conveniently manipulate and visualize data. And it allows you to import and export data and optimize results to many data formats. The graphs present the performance of the programs generated by GAMSP compared to GAMS. The reason for the superior performance of GAMS is the use of relational algebra. While PyOmo, GuroBPy, and JuMP require iterating over all elements of a set, GAMS uses relational algebra to process complex queries efficiently. Relational algebra originates from database theory and allows complex queries to be processed very efficiently without the need to iterate over all the database entries. For this reason, HY recommends the use of GAMS and not Python to handle the mathematical model. This is because the time in GAMS is significantly shorter. There are really no cost savings using Python as a free platform, as the cost of using the technology will be much higher. The performance of GAMS in generating and solving the mathematical model is superior to that of any Python library. Example of SQL connectivity generated by OPTEX. There are several free libraries that can be used with Python to facilitate the implementation of optimization models, among which HY knows are PyOmo and JCO. Major commercial solvers vendors provide their own connection to Python, as part of the license. GAMS Engine is a GAMS component designed to manage activities in the cloud. GAMS Engine is a server software that allows you to run GAMS models on centralized compute resources, either on premises or in the cloud. The engine is accessed through a gateway service, the broker in engine terminology, that provides a REST API. Jobs submitted through the broker are placed in a queue and from there are assigned to available GAMS workers. The results of the workers are collected by the broker and made available to the user. GAMS Engine is an API designed to run in cloud environments. It's an enterprise-grade system that runs on a server and offers features like high scalability, load balancing through a job queue, continuous updates, and much more. The GAMS engine automatically schedules jobs and assigns them to a GAMS worker available to solve them. Moreover, it comes with a powerful user management system that allows you to restrict your users' activities according to your organizational hierarchy. The GAMS engine can not only be controlled by a Miro application. Thanks to the use of OpenAPI, clients are accessible in various programming languages. GAMSP works seamlessly with GAMS Miro and GAMS Engine, allowing you to run your GAMSP optimization on your local machine or on your own server hardware, GAMS Engine 1, as well as on GAMS Engine SaaS, hosted on AWS Cloud Infrastructure. We make sure you have access to the right resources at any time. As George Bernard Shaw would say, some see the things that exist and wonder, why? But HY dreams things that never existed and wonders, why not? This free thinking has made HY a leading company in artificial intelligence for decision making. This thinking is enhanced by the alliance with GAMS. Thank you for your attention.